Hello guys, welcome to the video, and today we will be understanding nearest neighbor search, and this is the first approach. So this is part 1. In part 2 we will be discussing another technique, but this technique whatever today we are discussing, that is using regular index, and we will understand what that is and how that is helping us to determine that nearest search, and what that is basically used whenever we are using systems like Uber, then Lyft, and then we can have Foursquare, Uber, Lyft. Then we have to find out the nearest customer, we have to find out the nearest destiny. So in that case, this type of neighbor searching mechanism is becoming very much critical. So the first thing is, suppose you got lot of data points over here, and these data points are, having this overall space. Now you are, making a direction, like this is your x axis and this is your y axis, and now you are trying to find out something, and suppose you have some point over here, and within 1 mile radius you are trying to find out your people, right? And you are basically here actually, when we are talking about radius, normally we assume that the area is basically a circle, but here you can assume that for the simplicity purpose there is a square, and this square is having a radius of means 1 mile. Okay, so from the circular it's kind of an evolvement to square, and this evolvement is done because the simplicity of computation, nothing else. And how it make it simple, I am just discussing it. You will have a knowledge, you will have a understanding on this. Suppose you got this square and you have this point, and you want to understand like what are the points which lies in this square. So this is not perfectly fitted. I mean, all these points are, suppose here now we are targeting this point. Now you can take a projection on x-axis, and in this projection you got a point like x1, you got a point like x2, that's perfect, fine. And you take projection which is parallel to x-axis, and that goes on, right? There is another thing which will come on the y-axis as well, like this is your projection on y-axis, so you got something called y1, you got something called y2, and this projection lies on the axis which is parallel to your y-axis as well. Okay, now what we need to do, we have to find each of these points which stored as xy coordinate, and we need to store that in our database. So that means for to store this data, the schema of the database, how would it like? Let's see that one first. Suppose you got an id and you got x-axis value and you got a y-axis value, so all the data points you will be storing over here only. Now what you gonna do, for this whole ecosystem there are a lot of points, and you have the points, or you have the coordinate of those points in this database. You want to find out what is the points, what are the points which is lying in this square. So what is you are going to do? First you will go and you will perform range queries between x1 and x2. When you got the range queries values of between x1 and x2, basically you are getting this whole value, right? This whole value, but you don't need that one. You need only the intersection of these two areas, and that is this, right? So you need to perform another range queries on top of this result. So eventually, and that range query is going to happen from y1 to y2, because you want only these areas, right? So whatever the result is coming with your first range query, on top of that you will be running a second range query to understand like the intersection points, and you will get that point from the your database. So basically you have all the data in your database, and you are doing some range queries, actually two range queries. So let me write down, so that is our objective. Okay, so let me write down the SQL query which you can write over here. So you can write like select, and you want id, and you want id of those where you got your x between x1 and x2, right? So you have to say like x1 and x2, and whatever that is resulting, whatever that is providing an output, on top of that you are running another range query. So and you are doing y, your y, which lies between simple y1 and y2. So whatever the result is coming, on top of that you are doing another range queries considering yn and y2 values. Now what is the downside of this approach? There is a downside. Although the first query is going to run very fast, but the next time another range query is running, and that is running on the output of the first query, and that is going to take time because that is an expensive process. So that is the downside, is the second round, sorry, downside is the second your second query eventually will take time, second range query. So effectively whatever you are running, first plus second range query, is going to take time, and it is going to be an expensive process. So how you can get rid of that? Another important thing, if we talk from the perspective of downside, that is like your system is actually, whatever the data, whatever the things you are doing, that is actually stored in a persistent database, right? So we are doing that on top of persistent database. It is not an in-memory thing. So your interviewer can ask you like, can you make some arrangement on in-memory or on RAM? So, and we don't want this range query. He wants to see like what else you have, right? So you can go with binary search tree over here, where you can order the node by x value, and x value determines where the node goes. So suppose you got then x value, and you are trying to put a binary search tree over here. So it should like this, and what you are doing, you are making a range query on this binary search tree. Suppose this is your x1 and this is your x2, and you got some result like from here, here and here. So that is your answer, right? So with the help of the binary search tree, you can go with the range query. Now how that binary search tree actually handles the range query, it's a separate lecture altogether, and we will make a video on this. Go to that video and just have it, and have the concept, and you can discuss that concept in front of your interview if interviewer is interested to listen. Now the thing is, there are another approach, that is your third approach, you can say. In the third approach, you can just take a array, you can just take an array, and you can put your x values over here in sorted manner. That means your values are getting sorted. If it is getting sorted, then you can find easily a range between x1 and x2, right? You can find easily that range, and there is no difficulties to find it out. But I mean, you can find x1 easily, and you can go your iteration up to x2 until x2 comes, right? And you are making it kind of a filtering process, right? Then you can, on top of that filter, you can add the filtering of y1 and y2, right? That means you can put a filter. So what I'm trying to say, like you can sort this array, you can find x1 and x2 range, and you can add a filter on top of this result, saying that I want y1 in y2 with the result, I want to filter with the range of y as y1 and y2 on top of this result. So that is going to be faster, but there is a downside here as well. Whenever you want to put something, that is going to be a tough call, because you want to put something. So that is I would like to say, like, the entire process about this is a 2D stuff. First of all, this is a 2D stuff, means you are using a regular index. So we are doing all this process using regular index. There are other techniques as well. So here actually, with the help of this regular index 2D search process for determining the nearest neighbor, we have actually discussed 3 approaches: 1, 2 and 3, right? So these 3 approaches you can discuss with your interview when you are talking systems like Uber, Lyft and Foursquare, something like that. And we will be having some other techniques as well in our video, so just keep watching. Thanks a lot.